So real quick, I want to review multiplying out these binomials, particularly when we don't have all pluses and when we have coefficients for our x's that aren't 1. So what I'm going to do is I'm going to put each factor on the outside, and I usually put the x's down here. So this is x plus 4 and x minus 6. Over on the other one, I'm going to do 2x plus 1 and 3x plus 5. You don't have to do it this way, but when we start to reverse the process, it is more helpful because that's how I'm going to show it over and over again, because that's just the habit that I'm in. So when I multiply it out, x times x is x squared. X times positive 4 is 4x. X times negative 6 is negative 6x. And negative 6 times positive 4 is negative 24. So we were working with patterns on this. So this is x squared. I'm going to add my like terms, 4x and negative 6x, to get negative 2x, and then minus 24. So things that I want you to notice here when we do this. The first term and the last term are in opposite boxes. And then these two terms here are going to add up to my middle number. And if we put our, factors out here, the placement's going to be different, but the two terms that are in opposite corners make up our middle one, and the first and the last should be in opposite corners. Over on the other one, start with the 2x times 3x, which gives us 6x squared. 3x times 1 is going to give me 3x. 2x times 5 is going to give me 10x. And 5 times 1 is going to give me 5. So I have 6x squared. I'm going to combine my like terms here. 3x plus 10x is 13x, so plus 13x, and then plus 5. So again, my two middle terms are in opposite corners, and they add up to my one middle term. My first term and my last term also in opposite corners. But the patterns that existed with these, like this being 4 plus negative 6 is negative 2, and 4 times negative 6 is negative 24, that pattern is not the same with this, because if I take 1 plus 5, I get 6, not my middle term. 1 times 5 is 5, so that still works. But this 2x and the 3x, the fact that these added equals 6 is coincidental for this. It's not related. So in figuring out the pattern when our our a value is not 1, is a little bit trickier, so we have a process that we can use to handle that. So now what I have are two filled in boxes or area models that I'm going to figure out what the factors are for the outsides. So if I take this 3x squared minus 15x, 3 and negative 15, those are both divisible by 3. X squared and x are both divisible by x. So I'm going to take the 3x and divide it out to factor it out to put here. And then I figure out the rest based on that. So 3x times x gives me 3x squared. X times 1 gives me x. 3x times negative 5 gives me negative 15x. And then I double check, negative 5 times 1 gives me negative 5. So I've got 3x plus 1 times x minus 5 to get my factored form. Now, if I look at the inside of this area model, what this initially started out as was 3x squared, negative 15x plus x is negative 14x, and then minus 5. On the other one, this one is interesting because it can factor more than one way, because these both are divisible by 2x. So I'm going to go ahead and take out the 2x on this side. So 8x squared divided by 2x is, whoops, 4x. 4x times 2x, no, wait, that was the problem. Sorry, I was thinking 2x was the greatest common factor for both of these. That's not the case here. So 2x squared and 20x, they're both divisible by 2x, but they're also both divisible by 4x. And when we do this, we want to factor out the greatest common factor, not just a factor. That was what my problem was. So I'm going to take the 4x out here and then multiply 4x by 2x to get 8x squared. 2x times 1 is going to give me 2x. And then 4x times 5 is going to give me 20x. And then I always double check. 1 times 5 gives me 5. So my factored form here is going to be 4x plus 1 times 2x plus 5. And that's my fully factored form. So this one, if we were looking at where it started, the 8x squared plus 22x plus 5. So the only real patterns that we can figure out here, 4 times negative 5, or sorry, 1 times negative 5 is going to give me that last number. 1 times 5 gives me this last number. My first and my last terms are in opposite boxes. And then my numbers that add, my like terms that add up to my middle term are in opposite boxes as well. So we're going to use that in a little bit to start to figure out what these two terms are.